All right, so now we are starting the part where we have to do data interpretation in SAT. So this is the statistics part of SAT, the last section that we have to do. So first of all, we should be able to read data from diagrams. Okay. There are three different types of charts or diagrams that you will be tested on: bar charts, line graphs, and scatter plots. Okay. Bar charts you've seen before, line graphs as well you've seen before. What about scatter plots? Yeah, so all of you have seen these three different diagrams. That's all that you need to know in this topic. The mathematical concepts, the calculations are the same as what we have learned until now. There's nothing new in this. So this is just about practice. Okay, reading data, it's just about practice. So let's do some practice questions on this now. Okay. Okay, let's start this quickly. Fairly straightforward, not very difficult. So we can try to do this very quickly. The statements थोड़ी सी लंबी होती हैं. Just have to make sure that you understand them correctly. But otherwise, it's not that difficult. The line graph shows the value of a watch in dollars, appraised every 3 years after it was manufactured. So it is updated after every 3 years. What's the greatest average rate of change in the value of the watch in dollars per year between two successive appraisals shown in the graph? Now, make sure to pay attention to the axes and what's written there, the labels. Vertical axis represents price in dollars. Horizontal axis represents time in years. And time is changing at an interval of 3 units, 3 years. What's the greatest rate of change? Now, looking at the figure, can you identify the region where the rate of change is the greatest? Rate of change is gradient, right? The slope of the line. Which gradient is the steepest? This looks like the steepest, right? If you're unsure between these two, you can just verify that as well. But it's pretty clear that this is steeper because the change in vertical height is more as compared to the other ones. This is the region. Now, what's the change here? Now you have to be able to read the graph properly. Its axis, the values are changing by 600. What that means is this number here is going to be 300 more than 19,800, which is 20,100. That's this point, 20,100. And then this point is 21,300. What's the gradient? What's the rate of change per year now? 21300 minus 20100, right? Y2 minus Y1 over X2 minus X1, that's 12 minus 9. And that should give you the result. You can see what that is. What's this? 400. That's the rate of change. That's the average rate of change per year. Make sense? No problems? Okay, let's try another one. Researchers surveyed a group of 17 candidates applying for the same job. The scatter plot shows their ages and the number of hours they slept the night before the job interview. Which of the following is the closest to the age in years of the candidate who slept the least number of hours the night before the job interview? Look at the axes. Number of hours of sleep, age. Yes. Which candidate slept the least amount of time, least number of hours? Whatever is the lowest number on the graph, right? Because vertical axis represents the number of hours of sleep they had. This is the lowest number of lowest number on the graph, right? So what's the age? B. Yes. Yeah, I'm not sure. I'm not sure what job 8 years old can do. Maybe They want to be a Lego instructor, Lego baking instructor, something like that. Okay, 40, right? Is that okay? Okay, last example. 13 you are, 13 you are. 29. Okay, last question. Last question. According to the bar graph, the average mass of a wolf's brain is what fraction of the average mass of a pig's brain? Axes, they claim. What's the vertical axis? Brain's average mass. And here you have the different animals. Wolf's brain. What's the average mass? 120. And for pig, it is 180. Wolf's brain is what fraction of the mass of pig's brain? How do you write that? 120 over 180. That is 2 over 3. That's what you write down. 2 over 3. Okay, so it says the graph models the body temperature Y in degrees Celsius X minutes after the end of a 3-mile run, where X is between 0 and 10. Okay. On the X axis, you have X. On the Y axis, you have Y. You can see it in the diagram. Which of the following is closest to the predicted body temperature in degrees Celsius at the end of its 3-mile run? What does Y represent? It represents the body temperature of this thing X minutes after the end of a 3-mile run. What's the predicted body temperature at the end of the 3-mile run? Yes? C? C is 39. Where is that coming from? 3. This value? Does everyone agree? Question statement पढ़िए सही तरह से क्या लिखा है उसमें? Are they saying after 3 minutes? Remember, X represents time. When does the time start? Time starts at the end of this 3-mile run. What's the body temperature at the end of the 3-mile run then? 40.5. When the time starts. So right after the 3-mile run ends, the body temperature is 40.5, and within the next 10 minutes, it reduces to 37.5. At the end of that run, it's 40.5. Okay? So 3 minutes की बात नहीं हो रही थी, वो जो 3-mile run था, उसके end की बात हो रही थी. Make sense? So in questions like these, you will see that the difficulty level is not that much. It's not that high. But it's just about understanding the given question statement correctly. So you have to be very focused when you're reading the question statement so that you're not misinterpreting what it says. Okay, let's have a look at this now. The scatter plot shows Alex's commute time to work and his commute time from work for 4 days. For which of the 4 days was his total commute time to and from work the greatest? Look at the axes. Whenever you have a graph given, any diagram given, look at the axes first. What do the axes represent? Horizontal axis is commute time to work. Vertical axis is commute time from work. On which day is the total time travel the greatest? Total traveling time the greatest? In which direction is the time increasing on the x-axis? This direction. In which direction is time increasing on the vertical axis? In this direction. So you want the point that is towards top right, right? As far as possible from the origin towards top right. So there are two possibilities. It's either day 4 or day 3. उनका आपको देखना पड़ेगा, उनको count करना पड़ेगा. This is around 80 and 20, 80, 20, that's around 100 for day 3. What about day 4? 45 and 80, that's much more than 100, so it's supposed to be day 4. That's our answer. Is that okay? So day one and day two can be eliminated just by looking at the diagram visually, and you just have to focus on these two. All right, let's move on. Okay, now you have a line graph. The graph shows the price of platinum in dollars per ounce over a 10-year period between which 2 years was the average rate of change, dollars per ounce per year, dollars per ounce, that's the vertical axis, year, that's the horizontal axis, in which between which 2 years is the average rate of change the greatest. So wherever the gradient is the highest, right? This looks like the highest gradient. You can compare that with this as well, but this is the first one is much more steeper, right? 7 to 8. And that's C. Okay? No problems? Okay, let's try this. On the day of a medical evaluation, so take a minute to read the question statement, then we'll see what to do. Look at the axes first of all, glucose level, vertical axis, time, horizontal axis. So you understand what the graph is telling you? They're trying to see after how much time the glucose level comes back to the initial point, right? Wherever it started from. So before breakfast, after breakfast, when does the glucose level come to the same level again, right? And they're calling this glucose recovery time. So for breakfast, what's the recovery time? It starts from 140, comes back to 140 in how much time? 2.5 hours, right? And then for lunch, how much time does it take to come back to the initial level? 4 to 8, that's 4 hours. And they're asking, by how many hours is the recovery time after lunch greater than the recovery time after breakfast? So what's the difference between the two? 1.5, it should be A. Okay, 4 minus 2.5, that's A. Why did you subtract? Because they're saying, by how many hours is the recovery time after lunch greater than its recovery time after breakfast? So after lunch, it's 4. After breakfast, it's 2.5. It's greater by 1.5 hours. Okay. All right. Let's have a look at this bar chart now. So the vertical axis has some production, 1,000 metric tons. Okay. And the horizontal axis has years, production in year, mass and time. In which 2 consecutive years was the percentage increase in the annual salt production equal in absolute value to the percentage decrease from 2010 to 11? Okay, 10 to 11, there's a percentage decrease. Between which 2 years, this percentage decrease was the same as the percentage increase in that year. So first thing you should do is do this calculation. 2000 to 2011, what's the percentage decrease? How do you calculate that? New value minus old value divided by old value, right? What's the new value? 30. Old value? 40. So 30 minus 40 divided by 40, right? The starting point is 40 into 100%. What do you get from that? 25%. So the decrease is 25%. Between which 2 years is the increase also 25%? 2009 to 2010, it's going from 20 to 40. That's visibly 100% jump, right? So we can ignore that. 2012 to 13, this is 15, this is 20. What's that percentage increase? 5 over 15, 33%. That's also not correct, right? 2013 to 14, it's going from 20 to 25. What's that? 5 over 20, that's 25% increase, and that's what we wanted 2013 to 2014. We can check 14 to 15 as well. That is 25 to 35, 10 over 25, that will be greater than 25%. So 25% is only C, 2013 to 14. Make sense? Isn't it? And that's 25%. 5 over 20 into 100, 25%. Okay? Let's move on. Let's have a look at this. The graph models the gas mileage of a car and miles per gallon as a function of its speed and miles per hour. Okay. You have miles per gallon on the vertical axis, miles per hour on the horizontal axis. Based on the model, how many gallons of gas are needed to drive his car for 5 hours at a constant speed of 30 miles per hour? That's too many units. Miles per hour, miles per gallon. Then they're asking about constant speed. You have hours. What do we do? What is fixed? 5 hours. Time is 5 hours. Right? That could be a starting point. The time given is 5 hours. What else is given? The speed is 30 miles per hour. Can we find the distance traveled? Speed into time, right? What's the distance traveled? 5 into 30. What do we get from that? 5 into 30, that's 150 miles. That should be the distance traveled and this time. Now, what are they asking about? How many gallons of gas are needed to drive this much? 150 miles. Okay. What do we want at the end? Number of gallons. क्या करें? We have miles per gallon relation. Look at the speed of the car. Speed of the car is 30. When the speed of the car is 30, what's the mileage that you're getting? 25. So it's 25 miles per gallon at that speed. And you're traveling 150 miles. What's the number of gallons? You can use conversion factors if you want, or you can use ratios here as well. 25 miles per gallon. What about 150? 25 into 6 is 150. So 1 gallon into 6, that will be 6 gallons. You can just write this down directly. If you're unsure, you can use conversion factors if you remember that. Gallons chahiye na hame. You want to cancel out miles from here. So what do we do for that? We can say gallons over miles. We need this conversion factor. Gallons to miles. Taaki miles cancel ho jaye. What's the ratio from gallons to miles? 1 gallon to 25 miles. 150 over 25, what do we get from that? 6 gallons. And that's our answer. That's the amount of fuel needed to travel 150 miles at 30 miles per hour. Is that okay? No problems? All right, so that's all that you need to know about reading data in terms of concepts, as in it's just different types of graphs, bar graphs, curves like this, line graphs, right? You just need to be able to interpret them. Sometimes you have scatter plots as well. We saw one of those in the beginning as well, I think. Yeah, so you can have scatter plots like this as well. You need to be able to interpret them. All right? Yes. Ye wala? Okay, so what's the information that's given? He's traveling for 5 hours at a constant speed of 30 miles per hour. Can we find the distance traveled? 150 miles travel kiya. Okay. Distance to aa gaya hamare paas. This is the distance traveled. Now, we have a graph that shows what is the mileage of the car, as in how many miles you can travel per gallon at different speeds. So mileage of car varies depending on the speed you're driving it at. So if you drive a car, for instance, at 80 kilometers per hour, उसकी fuel consumption एक किसी level पे होगी. अगर आप उसको 150 किलोमीटर पर आवर पे चलाएंगे तो उसकी consumption per mile वो बढ़ जाएगी, right? So consumption depends on the speed you're driving the car at. Now you know the speed of the car is 30 miles per hour. So looking at the graph, you can basically figure out that 30 miles per hour pe what's the mileage that you're getting. Okay. So from the graph, you just have to read this much. You know you have 5 hours of time. 30 miles per hour is your speed. 30 miles per hour is your speed, and what's the mileage? 25 miles per gallon. 25 miles per gallon. You can just use conversion factors. What do you want at the end? Gallons. Gallons रखना है, बाकी सब कुछ cancel करवाने. Okay. Now hours and hours get cancelled here, right? Miles also need to be cancelled somehow. So we have miles per gallon here. If we reverse this, we can say it's 1 gallon to 25 miles. One gallon to 25 miles. Miles and miles also get cancelled. What are we left with? 5 into 30 divided by 25, and that should give you the result. That's 6 gallons. Is that okay? 5 into 30 वो पहले अलग अलग कर रहे थे ना. That's 150. अगर उसको इकट्ठा करना चाहें, we just do it all together. पहले हमने अलग अलग किया था. Now we have done it all together.